Vardi Director, Professor S.S. Pattnaik. Before joining Director NITTTR, Sir worked as Vice Chancellor of Biju Pattnaik University of Technology of Government of Odisha. Sir Pattnaik has done his postdoctoral from University of Utah, USA. And under the able guidance of Professor Pattnaik, 24 students have completed their PhDs and more than 50 students have completed their masters. Sir has many SCI and Scopus publications to his credit. And in addition to that, the one patent is in the kitty, the Sir's kitty. So Sir is recipient of Voicecast Fellowship from DST, and Sir has worked with several reputed bodies at the national level as well as at the international level. Professor Pattnaik is a known researcher in the field of antenna and soft computing and its applications to the biomedical. So if I go into details of Sir's profile, it will take almost 15 to 20 minutes. So as Sir has instructed to be brief. So with this brief introduction, I am inviting you to take over the session. Over to you, Sir.
Yeah, thank you, Dr. Balvinder. So let me open my presentation. So let's go for it. Is the screen visible?
Yes, sir. It's perfectly visible, sir.
Yes.
Okay. Well, participants, good afternoon. So, as requested by Dr. Balvinder, I would be giving you some perspectives how biomedical research to be taken up and what type of antenna issues should be considered in that. So, in that line, this is the title I have created for you, that bioelectromagnetic in new perspectives, because in this era of medical healthcare systems, if you see, the RF activities are of a very important significance, and RF activities needs to be handled with lot of efficient antennas, which are miniaturized, which are directional. At the same time, some are very broad wideband, some are very narrow band. So there are many issues to be discussed. So let me just give you some ideas so that you can think how you can go about the bioelectromagnetic based applications and how can you design for right kind of antenna for that. So before I go, why I am telling you these requirements, because if you see, it is a document which I came across next 100 years of research long back. Maybe you'll be surprised that this document I came across around 2010-11, where this document was prepared by a mixed group of Nobel laureates, and they had projected that next 100 years of research will dominate many areas, and one of the areas are these biological requirements areas. And if you see that, they talk about biological repairs, artificial organs, then electronics divided into body, whole body simulators, body specific drug design, body specific, organ specific drug design, communication problems between protein and genome, mass transportation with levitations, speed just below sound, ultralight electric vehicles, self-repairing metamaterials, radar with clear vision in fog. So if you see, there are many such areas which are coming, and one already this is in operational, like Chandigarh to Hisar. Hisar is a place in Haryana, and in Chandigarh to Hisar, there are now flying taxi which is flying. So you can 5 people can travel in that taxi. So this already is happening, But again, a sophistication is happening in this type of taxis, which are on-man taxis like that. People are working. This is a dream. It is expected that like the people will fly by themselves. So the research are on that the people can fly themselves, and that is what is the dream which is people are having. And there are also like the dream of having a underwater city, or maybe creating a city in the moon. So therefore, the things are moving in a different way. Even organ regenerations, like as you know, the artificial organs and the damaged organ, how to regenerate that organs, a lot of research are taking place. And this is a statistic. If you see, almost 1 lakh people are waiting for organ transplant in a country like US, and every day almost 8 of them they die. This is the statistic, which is very scary. If you see that the death rate for organ regeneration is this importance of the organ regeneration is very large requirements and important requirements. Similarly, Bionic Man. The Bionic Man, if you see, the applications are varied in different requirements, and the place where normal human being cannot enter, the Bionic Man can enter. So therefore, lot of this type of applications are happening, and people are also doing lot of activities in this direction. And obviously, the wearable devices for mainly for the healthcare systems, like we have a smart watch, smart spectacles. So like that, many such wearable devices are already in the market, and people are really going for it. And a lot of research are happening. And if you see these communications, if at all, let's say the person is in the blended type of situations, unable to, or paralytic situation, and the person is unable to communicate, in that type of situation, you're basically the IoT, Internet of Health Things, IOHT. The Internet of Health Things comes into picture. So when the Internet of Health Things is considered, then obviously a lot of this type of wearable sensors will be there, and the data will be coming from those wearable sensors, and it will be processed at the expert's end, maybe the doctor end, and accordingly the doctor will take a call on that. So when you are going for multiple wearable devices, so obviously the interference is expected. This the radiation pattern may affect each other. So there is a big challenge for the antenna engineers for this purpose. And since the medical science is going to be more dependent on this Internet of Health type of environments, so therefore these type of sensor-based health monitoring, sensors-based health diagnosis, these are the common approach which people are now exploring. So a lot of research options are available for the antenna engineers to take care of the wireless requirement in this type of Internet of Health things. Another areas, if you see, like crowdsourcing. The crowdsourcing is basically opinion mining, opinion polling, how to really go for it. So this type of research areas, if you see, also the sentiment analysis, this is also a component where the sentiment analysis are done, and accordingly, you can really go for motivating the students for going for a right kind of study. These are all wireless applications. When you want to really interact with a person, I think somebody has opened up his mic.
Monica, I think your mic is switched on. Monica. Sir, actually control is with Monica. Monica?
Yes, sir.
Your mic is open.
Yes, sir. Yes, sir.
Monica, kindly switch off your mic. Sir.
Yes, sir. Yes,
Monica,
sir.
what is this?
Sir, please.
So the sentiment analysis, if you see, the sentiment analysis, it is not a new thing now. 2014, there was a IEEE spectrum where the laboratory communications for sentiment analysis and the tools about the sentiment analysis was discussed. But if the sentiment analysis has to be taken up on an issue, and a wireless device has to be thought of to control, because today in this online era, as you know, the students they're going through a lot of stress, strain, and their sentiment needs to be really taken care. So even the small kids' sentiments are to be seen. Accordingly, the course materials, the instructional materials are to be steered. So in this type of situation, the sentiment analysis appears to be again a body wearing type of devices, and the body wearing devices, once it comes, it has to be wireless. Once it is a wireless system, then we antenna people come into picture. So therefore, there are many such areas where you'll see that you will have ample opportunity as an antenna engineer to work in signals and systems. And these signals, when it becomes a body centric, then it is biomedical signal. And in biomedical signal, if you are talking, then you'll see that there are behavioral signals. So the behavioral signals processing will lead to the informations, and informations will be collected. So that information will lead to the decision. So therefore, to get a signal process, informatics and decision, there may be AI, machine learning, so many things will come into picture. We are not there. But getting this biomedical signal with a minimal noise or without noise is our job. This is the job of the basically RF engineer. So that's the way that the RF engineer should look forward to giving a right kind of behavioral signals without any noise to the processor, so that the right behavioral signal is processed and the right kind of behavioral information is extracted, and those behavioral informations are interfaced with the experts, and therefore the study can be taken up rightly. So therefore the behavioral signal, if you see, they are different. So I'm not going to the compression, what type of signal distribution, all those things we would like to avoid. But basically one of the things which I'll tell you from the IEEE spectrum source which I took, that people are thinking of looking at their own DNA sequence that affects their characteristics. Suppose I am a short-term person, so how do I change myself? If I get my DNA sequence and start studying that, then I control the activities. So like that, many such interesting works are going on. And this is just to give an idea that the biomedical research is more moving towards the Tera-Hz communication area. Because as you know, the Tera-Hz is a very high frequency situations, and the Tera-Hz communication will go to a lot of miniaturizations, and the Tera-Hz communication is very well interacting with the biological behavioral signals type biological tissues. So therefore, biomedical signals analysis are more going towards the Tera-Hz communication, which is a costly affair at this stage, but the facilities are getting evolved and the laboratories are coming up in many good places. And the Tera-Hz biomedical communication is the future, which we see that there is a lot of things going to happen in Tera-Hz area. So those who are having the option of Tera-Hz related biological applications study, they should look forward to Tera-Hz antennas, sub-Tera-Hz windows. All those things can be explored. But in the near field situations, when we are going for our own way of applications, whatever is we are going for the body-to-body communication situations, then that is one of the areas that when your multiple sensors you are using, lot of this energy requirement will come, even if it is small in nature, but the energy requirement in terms of RA will be high. So how to reduce that? Those who are working in the energy area, they can think of in multiple sensor area like the Internet of Health things, which I am talking in that Internet of Health things, how to reduce your energy, and that so that the sensor can sustain for long time and energy used is less. And in that case, if multiple, like you think about a big hospitals, lot of beds, and these lot of beds are connected with many such independent wireless devices, and the amount of energy required there and the carbon emission out of those energies is going to be huge. So even though in a small research environment you think that it is nothing, but when you go for the cascading of those research environment, you'll see that a lot of energy research are also required in this situation. Now coming to the so this is the background that I wanted to share with you. Now let's see what type of precautions and what type of studies to be done. So as you know, so if we are going for the heart, it is a different type of study. If we are going for brain, you'll come across very interesting signals called alpha, delta, theta, beta. So the alpha is used for relaxation, beta is for concentration, delta is for dreamless sleep, and Like that, these waves are very low frequency waves, low amplitude waves, and these waves are having specific requirement in our body. And remember one thing: this behavioral signals or the body signals are very low in amplitudes. They get merged immediately with external noise or the instrument noise. So therefore, it has to be handled very carefully. So now in this type of study, there are this presentation you might have seen in multiple forum by me, that the behavior of the individuals depend on their minds or the mental conditions. If you are scolded, you are frustrated, then obviously your wave which you see is noisy type of wave which will be obtained in terms of the heart rate. So this is the heart rate behavior. Frustration is a mental condition. You see the frustration mind condition is controlling your heart rate, which is coming as noisy. But when you are going for appreciation type of situations, you are appreciated a lot and the heart rate is often during that time, then you get almost a noise-free rhythmic heart rate for individual. So if you see, depending on your mental conditions, this affects your heart rate. So your HRV gets changed. So therefore your behavior also, like if you are just very angry with somebody and you are really, your behavioral signal is a very spike type of signal which is coming. So that is your affecting your behavior. That behavior is affecting your mental condition. That mental condition is affecting your heart. So that's the way the behavioral signal will have a link. So now if you see, like those who are using Anulam Bilam, their behavioral signal is controlled by the respirations, and the respiration will change the heart rate, and heart rate will change the blood pressure. That is what our Yoga Guru, Yoga Guru Ramdev ji, he teaches us in terms of your Anulam Bilam. So how this the cardiac behavior and the relaxation approach, as already I've told you, if you see here, it is a cardiac synchronized alpha activity. Alpha is for relaxation, and it is a mental, this is a brain signal. Cardiac is your heart. So how the heart and brain are communicated, and because they communicate with each other, and their communication, how they are linked, you can see from this particular picture which I am bringing in front of you. So now a normal man, a normal person not having any appreciation or frustration, his distribution of the brain signal will be like this. So in a normal situation, when he is appreciated, you see the blue persons is getting completely replaced by pink and red persons. So that's the effect in the mind. When you are basically appreciated, your alpha activity changes, and when your alpha activities changes, your heart rate will go towards a smooth, continuous, this type of rhythmic signals. So you are in a very relaxed state. So this is a relaxed state situation. But this relaxed state also changes between female and male. So if you look into the female and male picture, the male relaxation signal gets distributed, the male's signals get distributed over their different part of the face and as well as the forehead, whereas in female case it is more concentrated in the your forehead region and in the central part of the brain region. So therefore they whenever something is told to a female in terms of appreciation, you'll see that immediately there is a spontaneous, very huggy type of reaction that my son has achieved and this thing. Whereas your father gives a small smile, and you sometimes feel that the father is not really appreciating you well. It is not true. It is very much there because of the physiological structures which the male and female are having, which is not in our hand. It is in the hand of the gods. So next, another thing which we saw came across the literature, that the electric field of the, I'll be slightly fast because I have a scheduled meeting, so I'll try to quickly sum up this. I'll come to the topic very quickly. So the electrical field strength of the heart is 60 times more than the electrical field strength of the brain. And if you see the magnetic field in terms of the heart and brain, then the heart magnetic field is 5,000 times greater than the magnetic field. So that it gives a option that, as you know, when you create a perturbations in a very high field, the small disturbance also can bring a large change. So therefore, when you are working in this biological type of signals analysis and especially heart and brain study, and or getting to get information from each like brain information from heart or heart information from brain, then it is better that you work in the area of heart first. Try to create a disturbance in the heart, because their fields are more. A small disturbance can create a visible impact in the heart, and that's the way it will link to the brain, and you can study that. So how to go to the heart or brain? So the best thing is the interface through the skin, our forehead skin or the hand skin. These skins are the place where when you create any disturbance, it goes through the heart to the brain. So the skin can be interface to your biological systems, and skin, when it is tapped with like this type of tissues, let me tell you, yes, biogel tissues like this, they are interfaced to the our biological skin, and this is your substrate which get interface, which has a coupling with the biological skin, and this artificial biogel will act as a substrate. Top of that, you are keeping your circuits and the antennas. So that's the way we go for it, and the skin is the best interface between your artificial circuit, the electrical circuit, and your natural skin. So that biogel skin is a requirement for this interface. So that's the way we see, and there is a lot of work already has happened in bionic skin, where the bionic skins are also so sensible, like when a very cold breeze is blowing. So like you are in a place like Simla and Manali when it is snowing, when your hands are not with gloves, when you keep it outside, a small cold wave also gives you a very strong sensation in your hand. So that type of sensations are now visible using the bionic skin. So the bionic skins are already developed by many researchers, and this type of sensitivity can be obtained. And even the studies shows that a lot of this forehead related biogel research are going on, and also the tattoos are now prepared in such a way that the tattoos type of structures are put on the bodies depending on the type of organ study which you are going to do, and to organ to which you want to go to interface with your RF signal. All those things are not new now. Things are already available. Only things that day by day the research are going on, how to miniaturize that, how to make it more efficient, how to make it more noise free, how to make it more adaptive. So all those things are happening, so you can get ample opportunity to do good work in these areas. Now in biological case, one of the very important thing is SAR. So how a SAR measurements takes place, I would like to show you this thing. So when you are talking about any biological research and RF interface with a biological tissue, remember that specific absorption rate cannot be ignored, because that is a quantitative parameter which gives how much this exposed signal is going to get deposited, and due to this deposition, is there going to be any effect on that particular organ and the neighboring organs, which is a very important aspect. One must keep in mind that without SAR study, the biological antenna study is incomplete. So you may design antenna, but this antenna will have how much influence on the organ, how much influence on the nearby organs. Those things needs to be studied. So therefore, there are two ways of doing this. One is going for the simulation. In simulations, the so-called the packages supplied by the company like CST, PICO, and many such company who are having the biological loop in their packages, they will not meet your advanced requirement. Earlier it was not there, now they have added a lot of loops in their packages, so you can do to a large extent some biological loading effect study and the biological interface studies using these packages, but this will not help you in your advanced research. So the advanced research required your own coding. So to do that coding, I'll suggest if you can master FDTD, finance difference time domain method, or moment method. Moment method is more computational consuming, Whereas finite time FDTD, the finite difference time domain method, or FDFD, finite difference frequency domain method, if you can master those type of coding technology after understanding how these analytical methods are working, this will give you a lot of freedom. This will give you a lot of freedom in your simulation environment to explore any type of organs, because how you have to just put the properties of those organs, electrical properties of those organs, and the simulator will take care of you, giving you the lot of information. Second aspect is the experiments, like I am here. So for this type of experiments, this is a costly issue. Absolutely, you cannot compromise with this. So you need a anechoic chamber. You need the materials to be purchased. You need a very good fabrication facilities to prepare the skull, prepare the materials, packing of these materials, all those things. So you need to really have a good fabrication facilities for doing this job. So like if you see here, this is a human skull. It has this material, artificial material, which has the electrical properties same as what my skull is having. So it is that type of material which has picked up after certain research and recommendation. So based on these materials, this skull has been prepared, and this skull materials is same as what our human being skull is having. So if anything is observed in the skull, it is equivalent to having absorption in your human head. Similarly, the pink region which you see here, this pink region is that soft tissue. So this soft tissue is basically the soft tissue which our ear section is having. So human ear section, whatever soft tissue is having, that electrical property is same as the electrical property of the pink material, which is the soft material which has been pushed inside this skull. So if you see here in the tip, there is a antenna visible. So this antenna radiation, whatever is coming here, it is assumed that the antenna radiation will have the same impact if I am going to hold or any human being is going to hold that. So if you see here, this antenna is visible. This is a Motorola telephone monopole antenna. So this is what is the study. The other side of the study was, the other side was that only. This antenna was not facing you, therefore you could not see. Now it is facing you, you could see it. So this is that experimental setup which I am showing you. Now coming to the next point, these tissue properties are to be picked up from the right kind of researchers. The people, there are a lot of researchers, they have published their results classifying the different body organs and the corresponding electrical properties. So these properties are to be mapped, which organs you are taking. So suppose, let's say you want to interact with the muscles. So the muscles has a relative dielectric constant of 51.76. So you have to pick that material, this electrical artificial material, which will have the same dielectric constant what as the muscles has. Similarly, it should have the same conductivity what is the muscles is having. So therefore, there are many research results available in these directions. You have to pick up the right kind of materials, map with the biological electrical properties, and those materials are to be used for your phantom preparing or the phantom construction. So now these materials are also frequency dependent. These properties are also frequency dependent. So that needs to be also taken care. You might have picked up something which is defined in 900 megahertz and you are trying to make it in 2.5 gigahertz. So that will not work. That needs to be the properties, electrical properties, conductive properties are to be picked up for the frequency or the band of frequency over which you want to work, and these properties should be almost all in the constant type of behavior. If at all it is varying, it should be within the tolerance limit. So now what is this SAR is all about? If you buy any phone, almost all everybody is now about know about this SAR, because SAR is specific absorption rate that gives a quantitative parameters for the amount of deposition of the exposed RF signal. So if you are getting exposed to any RF signal, how much actually is getting deposited in your body parts is quantified or calculated based on this SAR formula. And every phone, mobile phone or any wireless device which are sold now, they are sold with mention of what is the SAR value of that device. So you'll get to know that how much is going to really get deposited when I am going to use this device. So if you see here, the specific absorption rate is a very simple formula. It is dependent in your conductivity. If your conductivity is more, obviously more signal will be absorbed by you. So if you are a lossy material, so you'll be capturing more signal. Similarly, it depends on the peak field. So how much field actually is getting and landing on your particular organs. So if peak field is more, so obviously amount of signal deposited will be more. So therefore, it is conductivity and the peak field in numerator. But if suppose you are in a small size, total field is getting deposited in that, obviously impact will be more. If your volume is more, like this, if you see this is the density, so it is, if the volume is more, then obviously the signal will get distributed and your impact will be less. The SAR deposition will be less in a particular organs. So therefore, if it is inversely proportional to the volume, directly proportional to the conductivity and the electric field. So that's the way the SAR is calculated, and that needs to be seen. And the unit of this is watt per kg. So like in a head model, in a head, this SAR is basically 1.6 watt per kg. That is the one gram SAR. We defined that it should not really occupy more than 1.6 watt per kg. In 1 kg material of our head, it should not have more than 1.6 watt of power. Similarly, in hand, in this palm and hand, when you are going, this is exactly the double, 3.2 watt per kg. So now if you see how the SAR gets distributed, so this is a measurement which we took, Motorola one. These measurements will give you the data, because if you see here, this receiving antenna which is here in this place, this receiving antenna is receiving, so I'll be getting a pattern. In this pattern, I'll be seeing how the pattern is following, and in this based, I'll see that which person is depositing what. At the same times, I can do a FDTD simulation of that. So this is a FDTD simulation of the environment which is under experiment, to map whether the experiment and the simulations are ideally matching or not. So it's the same lambda by 4 antenna, 835 megahertz, we did the simulation using the FDTD code. So in this code, if you see this outcome of this simulation, you'll see that there are certain pink region, some yellow region, and the scale is here. The pink region are high deposit regions. It also has a neck deposit here also. So that gives a fair amount of idea to you that if this antenna is used near to ear, which part of the ear, which region of the ears are going to get affected because of the large amount of deposition. So that's the way the SAR distribution gives a very clear-cut ideas about the distribution of your peak field on the specified organs. Like you might have seen, you go for the current distribution, you go for the voltage distribution graphs to get the idea that in antenna how the current is flowing and how it is getting distributed over the structure. So similar type of things also can be visible in your SAR distributions. Now, another interesting study during our research, we found that the same power is released, keeping the frequency constant, and it was exposed to an adult 10-year-old child and a 5-year-old child also. So we saw that the deposition is maximum in your 5-year-old child. This small kid, they get maximum deposition. That's the reason it is said that keep your small kids away from the mobile phone. So when you are going for this, why it is happening? Because in the small head, when they are in this age, 5 to 10 years, the liquid component in our head is very large. The soft tissue is more lossy. So therefore, any signal which is landing on this type of head will be completely absorbed. It will be completely accepted. So in terms of the adult head and the small child head, if you see the size-wise, the head size is more for the adult. It will intercept maximum more signal than the child. But whatever signal is landing on the child head, maximum is getting deposited. It is affecting. Whereas whatever signal is landing on the adult, all are not getting absorbed. So therefore, there is a loss of signal. That is good. So nothing is getting observed, especially in this type of study. But like in cancerous study, we want that the cancerous tissue should absorb maximum RF signal so that it gets treated quickly, and the therapy is taken care accordingly. So that's the depending on what type of medical applications you have picked up, your requirement will be different. Here it is like impact of the mobile phone on the head, so we want that head should be less impacted, and this is what is the distribution. So again, this distribution gets changed based on your orientation. Sometimes you will be relaxed, sometimes you will be sleeping in the couch and using your phone. So therefore, orientation study is also required, which we did. If you see, this is again a numerical set of study which we did using the FDTD code, and in that different this type of orientations was done. It like allowing a person to be fully vertical, 30-degree tilted, 90-degree tilted, then going for your 45-degree tilted. Again in 90-degree, slightly keep your phone 90-degree, but 30-degree, and again you rotate your hand to some rotation angle. So all those multiple studies we did when I was in US, we did those type of activities. Even some of my students also they are trying now. So that is what is the idea, that this SAR study is more important when you are going for a biological antenna design. So now looking into the biological requirements, you will basically, the majority studies are confined to study of EEG, ECG and EMG. So if you see here, we are taking this recording here in the our own lab. It was a study during my presence during 14-15 when I was here. So one of my students, he is in a normal EEG condition. ECG also is taken simultaneously because we were going for a coherent study between your EEG and ECG. So his ECG also is considered getting recorded simultaneously, where the EEG is shown here. So if you see here, we use a 19-letter EEG recording system which is available in our lab, and the boy was asked to keep the eye closed so that the blinking noise can be avoided. So after that, once the EEG recording is done in a normal situation, the boy was asked to make a call. Sorry, during a call, yes. He was asked to make a call, and we took all precautions. Remember one thing, the cord should not act as an antenna. It will catch signal. So the cord should be, before that, should be tested and shown in absence of any external noise. The cord is normal, not having any EMI. When you are giving external noise like antenna is radiating, it should also not catching any external signal. So whatever is coming through a physiological sensation, which the sensors are going taking this data. So once it is recorded, similarly you see the ECG is also recorded like this. Like we used to have a 3 node. One is on the roof, like if you see here, they fixed here. One is in my leg, another 2 are here. So similarly, this boy was asked to be here. 2 of his hands are also having this recording, also leg. So that's why the EEGs are simultaneously connected and recorded. So now if you see my ECG in this case, in a normal situation when I am not using the phone, it is very well within the limit, like it doesn't go from, it varies between 72 to 78. Even only this region it is having some issues, otherwise it's 72 to 75. When we start, I make a call. When I start making a call, if you see, my ECG level has gone beyond 79. So this HRV which you are seeing here, it has gone beyond 79, which was in normal situation was less than 78. Now as I start going for the transmission mode, calling using my phone, it has gone up. Similarly in receiving mode, if you see, here also it has a variation, it is more than 79. And so receiving and transmitting mode, they have different distribution. Why? Because in receiving signal, you see, sometimes it will be peak, sometimes you lose the signal. So those situations were happening, and that is the way we have seen. Next, we go for certain people. There are certain people you'll find this type of distributions comes, and it is because The inverted QRS is seen here in their own ECG, but it is not any abnormality. It is natural. That is what the doctor told us, because in this type of study, always you have to keep a doctor with you also. So you have to consult that doctor. So if you see, there is also a appreciable difference in the normal conditions, the transmission condition and receiving condition. So there is a specific different if you see. Here you can very well understand. When you go for the power spectral density analysis of this signal, so the power spectral density of this particular subject in transmission mode, this shape is like this. If you see, this is a peak. When I go to the receiving mode, you see there is a change. Earlier, such a multiple peaks was not there. In receiving mode, this central peak is getting up. If you mark, the central peak is getting up, the small peak is getting enlarged, elongated. So that's the way there is a change. So it clearly shows that when we are having a mobile communication, our heart and brain, they are when recorded, they are going through this type of situation. Similarly, the people who are using phone for considerable time, you'll see that their normal heart rate is also very high. So normal situations, the heart rate is also very high. So similarly, we made a study that sometimes the people, they keep their phone in the front pocket, that. So these studies also we took. Then after taking this signal, we use right kind of filter. Then we started segmenting. As you know, the RR interval, QRS, PQ, PRQ, or QT, QTC, like that, we started segmenting that. And the type of modes which we studied during that time is 2G and 4G, 3G phone. 4G and the smartphone we have not done yet, because maybe the new candidate will be doing that. So our new PhD student will be handling that. So the 2G, 3G, again, transmission and receiving mode, both the things are here. If you see here, the TX is for transmission, RX is receiver, and the segmented values based on the channel 1, channel 2, channel 3, the signals are here. Then in the study, we try to find out the parameters. So linear and non-linear parameters we have already, we consider. So the HRP analysis we did in terms of the RR interval, and if you see here, the parameters are frequencies, sympathetic, vagal, bits per minute, and also some standard deviation things. So like that, the linear, non-linear parameters we consider. So now I'll go show you some more parametrics analysis, even non-linear parameters like entropy. So those things also were considered, because you cannot leave any of the parameters in these situations to map with your EEG signal. Now to do this type of research, you need wearable antennas. Because the uniform, the patient uniform is important. One is putting on the body, another is uniform-based research. When you are going for the uniform-based research, my student Joshi might have discussed a lot of thing with your wearable system. It is his first design for a school bag antenna. So if you see this design, these needles are here and there. The needle gap is leading to air gaps, and because you have to consider this thing in your simulations. So therefore, this type of studies required very specific simulation parameters to be considered, so that your simulation results doesn't vary much from the experimental measurements. Because if you see, I prepared a cloth antenna, and you see that my cloth antenna is not matching, because all these points are giving a lot of air gaps, and the air gaps will lead to a substantive characteristics change, and that substantial characteristics change will affect your antenna performance. Similarly, there is a belt. The belt will go through a bending effect. The uniform will go through crease. So it may be crumbling or crease. So those things are to be considered. Again, if you see, the substrates are also going to vary. Sometimes they are polyester, sometimes you are jean, sometimes pure cottons. So you will be using this type of substrate. So, and in this, after fixing, the current studies and the voltage studies, the field studies are very important. Once such studies we showed you. Similarly, the bending effect is studied using the antenna fixed, it is experimental studies. Also compared with the simulation results, my group actually Mr. Dhanbir Mandal, who is now a faculty in lovely professional, he is very much aware of the FDTD code, and he works in the area of crumbling study, bending study, or creasing study of the antennas. So he has developed his own code, and it is working well. But to map that, whether the code is right or wrong, so this type of bendings are created, their angles are measured, and with that angle simulation is done. And based on the simulation, the experimental results which are taken, those things are compared, and the code is vetted. Similarly, if you see here, this is a cap. Again, a antenna is the array is fixed here in the seat of the car. So if you see the antenna size here, almost on one size. It is the substrate. If you see here, this is the substrate, and the copper tape is fixed on top of that. It is very top. This is a rough fabrication which I am showing, because small tape you have to cut, and this total size is not actually more than 1 coin. So now yesterday I was told that Joshi has taken a good lecture on wearable antenna. I'll skip that, because he is the person now who can be contacted for giving you a lot of inputs in the wearable antenna. Initially he was doing this thing when he was here during his PhD time. So now if you see, the antenna in this biological scenario requires a different type of varieties of applications. Sometimes you require the very directional antennas. The antenna should not give a signal which is going to interfere. Very directional, large bandwidth, because you can take care of frequency from. Sometimes very directional, narrow bandwidth. So to handle this type of antennas, we started exploring which type of antenna can be best suitable. So once a structure is shown here, it is and sometimes the signal requirement to penetrate to the lower organ is important. So you need very directional and high power signals. So array system is required. So this is one such RS antenna 2-element array I am showing you. This is simulated and fabricated also. And if you look here, the idea was to create a metamaterial concept. The concentric rings are created, but the concentric ring is created in the ground plane. So if you see the substrate, there is a ground plane behind. So in the ground plane, we started creating the substrate. So the bottom view and top view of the antenna is shown here. This is the design. So this is a different type of metamaterial antenna fabricated in our place. And finally, if you look, this is the fabricated antenna, which is available here. It is FR4 material only. So, no, this is Rogers material, sorry. So similarly, multiple split ring, not only 2 split ring for material, multiple split ring with multiple feed point. So that when you are going here, it is single feed point we have discussed, but there can be a multiple feed point, because it will take care of your multi-band, multi-gain requirements. So in biological applications, you have to explore those things. What are the multi-band requirement? What is the multi-gain requirement? So that you have to give less power. Some places you have to give large power depending on the organ position. So that's the way. This is one such antenna which was derived, discussed mathematically. Another antenna is the square slotted patch antenna. So my group, they do a lot of activities. Then this square slotted patch antenna was loaded with a metamaterial. This is a metamaterial. So this metamaterial is loading this antenna. So there is a parasitic effect on this. So these effects are also seen, how these effects will change your current distribution. If you see this, in this case, the antenna is here. The parasitic elements is here. The parasitic, the antenna is excited by this from this place, whereas maximum of the signal is going towards your metamaterial loading. So that's the way, like the simulation will help you. Similarly, if you see here how a parasitic metamaterial loading is done, this is simply a patch microstrip antenna loaded with your concentric metamaterials. So the array of concentric metamaterials. This study also we did for biomedical application. These are all biomedical applications antenna which I'm bringing in front of you. So if you see the resonant frequency gets changed when loaded, and this, if you look here, unloaded situation is this. When you are loading, you have two different distinct frequency to work. So therefore, same antenna with different type of loading, I can create multiple such frequencies. That is the objective in this design. If you see this, the design is meant for that. So it was objective to design such situation that one excitation you get multiple such loops, and accordingly your requirement you can fulfill. Now, even we create hole here, is this one. We have created holes here. When you load this is inductive loading. When you put a length, it is inductive. There is a separation, it is capacitive. This hole will give you capacitive loading. So like that, the inductive capacitive loading by a hole, by a parasitic element, this takes place, and you can see that the via hole has further improved. It is without hole. This one is without any parasitic metamaterial. When metamaterial is loaded, this when metamaterial with hole loaded here, you see the range over which the antenna is working. This is really interesting to see that the antenna is quite wideband now, and it can really work in multiple band. So that's the way the multiple band requirement of the biological antenna is taken care. So in biological antenna, as you know, SAR measurement, multiple band, multiple range of gain, these are all required. If you see here, one interesting thing, at 8.7 gigahertz, 3.3 dBi, and 9.75 gigahertz, it is only 1.4 dBi. So that is what, that a controlled radiations is possible, controlled exposure is possible if you have this type of antennas in place. And like that, varieties of antennas, you can look here and remember one thing, simply doing simulation or fabrication will not do. A good understanding is that you have to draw an equivalent circuit, get the equivalent circuit parameters derived from the equivalent circuits, and accordingly put those parameters in your simulation method so that the computational time will be less and you will be reaching the accuracy as quickly. So that's the way the equivalent analysis needs to be also done. And this, when you are doing this equivalence analysis, you look when this type of antennas, normal antenna are putting towards the head or hand or any type of organs, those organs are become a load. So you have to bring those organs characteristics, electrical parameters, create a electrical equivalent load for that, and accordingly you have to make a study. So the basic purpose of showing you all those things, we are bringing a SSR and trying to find out the load. Similarly, you will bring a phantom's electrical property and will find out the load in terms of the equivalent things. So similarly, if you see the equivalent circuit for metallic via wall, which is very difficult, but my students that did it, so they could come out with a lot of this loading condition, input impedance, calculation like that. So what I suggest that in case if you are looking forward to going for a biological antenna applications, then ensure that this biological antenna applications, SAR study is not neglected, loading is not neglected, equivalent studies is not neglected, because input and impedance matching, the matching condition will get affected by that. And if your matching condition gets affected, your radiation pattern will get affected, radiation gain will get affected, your efficiency will get affected. Similarly, the polarization study needs to be done, the mutual coupling study and the self-inductance study. These are also to be considered. You cannot really neglect that. So biological antenna is a future, why future? It is a present and future requirement. It has a lot of scope, but this is a challenging area. Let me be honestly admit you that you need a group of doctors to also certify your results when you are interacting with the body organs, the radiation which is coming out. whether it is a physiological change, whether it is something different is coming, they should also certify, yes, this is because of your radiation it is happening. Then second thing is that unless you take care of all those things, it will not be very satisfying for you, and it cannot be accepted. Second thing is that the biological antenna reviews are slightly tough, because a lot of things are asked. Your test bench vetting is a very important aspect. Your ethical committee's approval is also very important aspect if you are going for a very large exposure type of situation. So, and if you are going for a blind study, then you must define what is the single blind, double blind study. So there are parameters to be fulfilled. But this is having a lot of requirement now. As we are going towards the body, wearable medical devices, or much more sensor-based healthcare system, Internet of Health things is going to be the priority in this era. So therefore, you as an antenna engineer, let's be focused, and you can really create a name for yourself if you do a sequence systematic activities like that. Design an antenna, study its various parameters, study its various loading conditions, see the SAR distribution of that, and give a right kind of perspectives to the engineers, the manufacturer who are looking forward to this antenna. With this word, at this moment, I would like to stop because I have to go for another meeting at 1:30. And maybe you can raise question to Balvinder, he will try to answer, or you can raise question for wearable antenna to Dr. Joshi. They are all my students and capable students. That's why I'm referring their name. So in normal antenna situation like fractal antenna, Dr. Balvinder has done a lot of work. So on fractal antenna, you can ask him. In like dielectric loading metamaterial antenna, one Silas Mishra is there, so you can ask him. In FDTD code, Dr. Dhanbir Mandal is my student. Again, you can ask on FDTD code to him. And wearable antenna, Joshi is there. So that way, if you are having any primary problem, you can talk to these people. Beyond that, if you have specific some advanced level of problem, you can come through your email to me. I'll try to answer your questions. So that's the way at this stage. Thank you so much. God bless all of you.
Thank you very much, sir, for delivering so informative and interesting lecture. So always we learn many new things whenever we have listen lectures from you, sir. Thank you very much for sparing time from your busy schedule.
Well, Minder, I'm slightly sorry today because I was rushing fast because I got delayed. Secondly, because I had another PowerPoint to show them, like ACG is slightly some extra what I'm talking nowadays, different than that. But I'm sorry I could not show them that. PPT is there, and we have stopped schedule today. Actually, a lot of tight schedule for me. In fact, I didn't take breakfast today. I rushed for 10 o'clock because yesterday 10 o'clock only we went from that place, Then morning I got up after my morning exercise. That I was getting delayed for 10 o'clock inauguration because today we had that international lecture.
Yes, sir.
So
yes, sir.
Now also, since I have to continue, I have to rush home, get something, a small bite. Then I'll come back and attend again meeting. So that's the reason I'm hurrying up. Okay.
Thank you, sir. Thank you very much for your time. So you have covered in short time. You have covered many things, sir. Thank you so much, sir.
Thank you. Thank you. Bye.
Thank you. So, dear participants, so with this we have covered all the technical sessions of this STC. So at this point of time, I would like to have feedback from your side. So we will not be having formal validation feedback session in the afternoon. So in the afternoon, I will be sharing a link and that link will be having a Google form. You all are required to fill that feedback form. So that is a official requirement. So before closing down the session, so if anyone would like to share his or her views about the STCs, about the sessions conducted in these 5 days, so I would be very happy to hear your views. Any one of the participants, please. Any one of the participants?
Yes, sir. Yes. This is Deepinder.
Yes, sir. Please.
Sir, we want that there should be hand practice of the particular designing of antennas is required as an assignment.
Actually, when we are conducting this STC in physical mode at our lab, so because we have software, then we do those types of assignment. But why I have not given those types of assignment? Because many of you might not be having the softwares. So that is
Okay.
the reason. That is the reason I did not assign any activity requiring simulation or any type of experimentation because of the constraints considering online. But definitely, when you are coming to attend such type of STCs at NITTTR, so you will get a lot of activities to do in our lab.
Okay, sir, what is the particular frequency range in your lab, sir, for testing of an antenna?
So we have up to 20 gigahertz.
Okay, okay.
Yeah, so you are welcome.
And fabrication facilities you are having, sir?
Yeah, we are fabricating in house. Even we are fabricating using subtractive manufacturing as well as additive manufacturing. So using 3D printing, we are also manufacturing. Then using
Okay.
that chemical etching and automatic PCB machine. So we are having variety of fabrication facilities
Okay.
at our lab. Yeah.
Okay. Okay. Thank you, sir.
Yeah. Any of the other participants, please?
Hello, sir. Good
Haan ji,
afternoon,
sir.
Balwinder sir. I'm
Haan ji,
Jaswant
good
Singh.
afternoon.
We shall be thankful if links of the forthcoming sessions provided on our email IDs, so that we people will try to join NITTR Chandigarh for the offline courses.
Definitely, Swanji. Now all the participants is in my mailing list. So every
Yes, sir,
activity which I will be planning in near future,
yes,
so
sir.
you will be
Definitely
getting
that
those
will
links.
add good kind of things and flavors in our research work. Thank you, sir.
So that you will be getting all the invitations from my side about my upcoming workshops and STCs. So that will be there.
Thank you, sir. So kind.
And any other participant who wants to share his or her views, please?
So participants are asking for feedback links.
Okay, so the feedback link will be shared through Google Classroom, and I will email you all the feedback form link. So that I will be sharing in the afternoon. So, and I want to also let you know all about the certificate procedure. So there will be no test, as someone has asked about the test. So there is no test for STC. The only thing is that we will be marking your attendance. So we will be taking attendance from the Google Meet logbook. So then after marking your attendance, matching your attendance, then we'll be issuing e-certificates, and you need to download those e-certificates through your portal. So while applying the STC, you have created username password. So you have to use the same portal, same username password, and certificate will be available there. But it will take around 10 days because we have to sort out your attendance. Then we have to fill the attendance in the portal. Then certificate will be generated. So you can expect your certificates after 10 days. And in the meantime, I will also share all the PPTs and the links of the recorded lectures through the Google Classroom. That again, those links will be shared during next week. But today I will be sharing the link for feedback form. So you all are required to kindly fill that feedback form. So the link of which I will be sharing through email as well as through Google Classroom. And if it is anybody is not there in Google Classroom, then kindly email me that your name is not there. So from email I will come to know. Then I will add those participants to Google Classroom. So with this, now I would like to thank all the speakers of this particular STC who have shared their views, and they have taken their time from their busy schedules to share their views with all of us. And then I would like to share all the participants for showing interest in this STC and cooperating in various sessions. So I would expect all of you to be part of my upcoming STCs also. So, and you can mail me anytime if you want to discuss any issue related to this STC or in general related to the topic of the STC or the topic of antenna research. So I will be very happy to interact with you. So, and in the end, I would like to thank Director NITTTR and HOD EC for providing this support for conducting this STC. I am also thankful to the media department, especially Harjot and Monica, for efficiently handling the sessions. So thank you one and all for your participation in the STC. Thank you.
Thank you.
Thank you, sir. Thank